Most people approach learning like they are filling a bucket with water, slowly, drop by drop, hoping it will eventually be full. But in high-performance environments, that method is useless. By the time your bucket is half filled, the game has already moved on. The reality is simple. In a world where industries evolve monthly and competition learns faster than ever, your ability to absorb, retain, and apply information ahead of others is the difference between leading the field and becoming irrelevant. The advantage doesn't go to the person who learns the most. It goes to the person who learns the fastest and makes it stick. That is where the protocol for accelerated learning comes in. A system designed to take your brain from passive note-taking to instant skill deployment. Think of your brain as a high-end computer. The hardware is already powerful, but most people run outdated software for learning, the same inefficient approach they were taught in school. The fix is not more willpower. The fix is upgrading the operating system so the input-to-output time is nearly zero. Step 1 is priming the brain for absorption before the learning begins. Neuroscience is clear on this. Your brain learns best when it has a clear, emotionally relevant target. That means you never sit down to learn something without defining exactly how and where you will use it within the next 72 hours. This creates what neuroscientists call a salience map. Your brain starts tagging incoming information as important because it sees a near-term application. To apply this, write down a one-sentence mission before starting any learning session. I will use this technique in my client meeting on Thursday, or I will apply this formula to my portfolio analysis tomorrow morning. You have now primed your brain to treat every fact as a tool, not trivia. Step 2 is encoding at speed. Traditional learning is linear. You read, you highlight, you move on. High performers use active encoding, which means you constantly transform incoming data into your own words, examples, and models. This engages multiple neural circuits at once, creating stronger memory traces. The application is simple. After every 5 to 7 minutes of input, pause and summarize the key point out loud as if you were teaching it to someone who has no background in the topic. This forces the brain to compress and reorganize information, which is what builds retrievable knowledge. Step 3 is embedding the knowledge into long-term memory through spaced activation. Forget cramming. Memory is not built in the moment of learning. It is built in the moments of recall. The hippocampus, your brain's memory gateway, strengthens connections each time you retrieve a piece of information without looking at your notes. The protocol here is to review new knowledge 3 times, once after 10 minutes, again after 24 hours, and again after 7 days. Each review should be active. You try to recall first, then check for accuracy. This timing sequence is based on the brain's natural forgetting curve and locks the information in place with minimal total study time. Step 4 is immediate application. Knowledge that is not used quickly gets tagged as low priority by the brain and is pruned away. The fastest way to cement new learning is to execute it in a live environment within 72 hours. This could mean teaching it to a colleague, using it in a project, or even applying it to a small test scenario. You are telling your brain, this is part of our operating system now, which shifts it from short-term storage into the neural networks you use for real-world execution. Step 5 is feedback integration. The brain refines skills fastest when it receives a clear signal of what worked and what didn't. This is why elite athletes improve more in a month than amateurs do in a year. Their feedback loop is tight. For your learning, this means after applying a new skill, you immediately identify one micro-adjustment that will improve it next time. It could be as simple as adjusting how you phrase a question in a sales call or refining the order in which you run an analysis. These micro-adjustments compound rapidly, turning early competence into mastery. Step 6 is layered learning. This is where you get ahead of the competition. Most people learn one skill at a time and then move on to the next, leaving the first one to decay. In the protocol for accelerated learning, you stack related skills so they reinforce each other. If you are learning negotiation, you also study body language and cognitive biases. If you are learning coding, you simultaneously study problem decomposition and algorithm design. This creates a neural mesh, a network of interlinked concepts that make recall faster and application more flexible. Step 7 is strategic forgetting. High performers know they cannot retain everything, and trying to do so wastes cognitive bandwidth. You need to identify the 20% of your learning that produces 80% of your results and deliberately let go of the rest. This frees up mental space for new high-leverage information. The way to do this is to review your knowledge bank monthly and archive any information you have not used in the last 60 days. It is not deleted forever. It is simply moved out of your primary focus so it doesn't slow down access to what matters now. Step 8 is state management. The speed and quality of your learning depend heavily on your neurochemical environment. You cannot expect maximum retention if you are tired, distracted, or stressed. The optimal learning state combines alertness with calm focus, a balance of dopamine, acetylcholine, and low cortisol. You can create this state deliberately with a short pre-learning routine, a brief movement burst to raise alertness, followed by controlled breathing to stabilize focus. This primes the brain's attentional networks and opens the gates for faster encoding. Step 9 is pattern recognition training. The more patterns you can recognize in new information, the less raw data you need to store. Experts in any field are essentially pattern libraries. They have seen enough examples that they can connect new situations to old templates instantly. You can train this by regularly asking yourself, what does this remind me of, every time you encounter new material? By linking new knowledge to an existing framework, you reduce learning time and increase retrieval speed under pressure. Step 10 is acceleration through constraints. This may sound counterintuitive, but limiting your available time or resources during practice forces the brain to optimize faster. If you give yourself all day to learn a concept, you will unconsciously slow down. If you give yourself 40 minutes, you focus on extracting the essence and applying it immediately. This builds the skill of distillation, which is a hallmark of high-speed learners. When you run all 10 steps together, priming, active encoding, spaced activation, immediate application, feedback integration, layered learning, strategic forgetting, state management, pattern recognition, and acceleration through constraints, you are no longer learning in the traditional sense. You are building a high-speed neural architecture designed for dominance. In a competitive landscape, this is how you stay ahead of the curve instead of chasing it. To push this protocol even further, you need to integrate meta-learning, the skill of learning how you learn best. This is the layer that most people never reach because they assume one method fits all content. But the brain processes different categories of information through different neural circuits. Motor skills like playing an instrument are stored and refined in the cerebellum and basal ganglia, while abstract concepts and strategic thinking rely more heavily on the prefrontal cortex and associative networks. When you align your learning method to the specific brain systems engaged by that skill, you dramatically shorten the path to mastery. For example, if you are learning a physical skill, you need more frequent micro-repetitions with immediate sensory feedback, whereas a conceptual skill benefits from longer sessions with deliberate recall and interleaving, mixing related topics so the brain learns to discriminate and apply them flexibly. The actionable move here is to categorize every skill you are learning as physical, conceptual, or hybrid, and then match your method accordingly. Physical skills get high-frequency, low-duration practice sets. Conceptual skills get spaced recall and scenario application. Hybrid skills like public speaking combine both. You rehearse content while also training delivery under realistic conditions. Another accelerator is contextual variation. Your brain encodes not just the information but also the context in which you learn it. If you only study in one environment, recall can be weaker in other settings. By changing locations, times of day, or even your body position while practicing, you teach your brain to retrieve the skill in any situation. This is especially critical for high-stakes performance because real life is never as controlled as a training environment. The simplest way to apply this is to deliberately practice in at least 3 different contexts before you consider a skill operational. The next layer is retrieval under stress. If you cannot access knowledge or skills when the stakes are high, they are useless. Stress physiology narrows your attentional field and can block retrieval pathways if you have never practiced with elevated arousal. You need to inoculate your brain against this by simulating stress in training. That could mean adding a time limit, introducing background noise, or practicing in front of a live audience. Over time, this builds neural resilience, allowing you to maintain both speed and accuracy under pressure. It's the same principle used in military and emergency medicine training. Practice harder than the real thing, so the real thing feels easier. You should also build a personal learning dashboard. This is not about tracking everything you know. It's about tracking active skill acquisition cycles. List the skills you are currently upgrading, the specific next use cases for each, and the feedback loops you've established. This keeps your focus tight and ensures no skill stagnates or slips into decay unnoticed. Reviewing this dashboard weekly forces you to make conscious choices about where to allocate learning energy and prevents the common trap of spreading yourself too thin. Finally, you must integrate recovery into accelerated learning. Neuroplasticity, the brain's ability to form new connections, occurs not during the input, but during the rest periods after it. Sleep is the single most important accelerator here. During deep sleep, the brain replays neural activity from your learning sessions, strengthening relevant pathways and pruning irrelevant ones. If you compromise on sleep, you are literally throwing away part of your training. Short, deliberate breaks between learning sprints also enhance retention by giving the brain time to consolidate and organize data. This means that overtraining without adequate recovery can actually make you slower and less precise over time, even if you are putting in more hours. When you combine meta-learning alignment, contextual variation, stress inoculation, targeted tracking, and deliberate recovery with the original 10 steps of the protocol, you are operating at a level that makes conventional learning look archaic. You are no longer in the same race as everyone else. They are still filling their buckets drop by drop while you are running a high-speed pipeline from input to execution. You don't just keep up with the pace of change, you set it. The practical reality is this. In any competitive domain, the market rewards those who can identify new knowledge early, integrate it quickly, and deploy it effectively before the rest of the field has even processed it. That is the edge this protocol gives you. The faster you install it into your operating system, the sooner you move from reacting to leading. And once you are leading, you are playing a different game entirely, one where others are chasing your standard instead of you chasing theirs. If you are serious about building a full arsenal of mental codes that make you uncatchable in your field, subscribe to Success Code now, because what we covered today is only one weapon in the toolkit. Every week, we release new protocols designed to hardwire performance advantages into your brain, so that in the moments that matter, you are not thinking about how to win, you are already executing.